Okay, now we're going to memorize these conversions because I think these conversions are very useful if you don't want to use long division. Otherwise, yeah, you're going to have to use long divisions to convert some fractions that to decimals that are really difficult for us to change the base to a 10, 100, or 1,000, right? So if we can't change that denominator to 10, 100, or 1,000, it's very hard for us to use our trick that we talked about previously in the video. So hence, these are conversions that I want you to memorize. Some of them you already know, like 1 over 2 is a half, is 0.5. 1 quarter is 0.25. These are the ones that you should know. Some of the other ones that are tricky are the 1/3. For example, the 1/3 is 0.3 repeating. 1 over 5 you should know because that's 0.2, and 0.2 added to itself 5 times is 1 whole. So 1 over 6 is also a tricky one. But just as a fun fact, 1 over 6 is technically just half of 1/3. 1 over 7 is unique, but it's also one you should remember. 1 over 8, that's an interesting one. Technically, that's actually half of 1 quarter. Because notice 0.125 plus 0.125 is simply 0.25. So if you times 0.125 by 2, you simply get 0.25. 1 over 9 is technically a third of 1/3. And then 1 over 10 is just half of 1 over 5. So let's talk about how we can, let's just, I guess, practice on some problems that are difficult to solve because we can't convert the base to tens, hundreds, or thousands very easily. Okay, now let's go over this example using long division. So I have 5 over 8, which is actually just 5 divided by 8. We're going to try to solve it with long division first. So if you recall for long division, the 5 goes on the inside and the 8 goes on the outside because the 5 is the numerator. The numerator always goes on the inside of my long division, and the 8 goes on the outside because it's the denominator. Hence now, let's ask ourselves this question. How many times does 8 go into 5? In this case, it would be 0 times because 8 times 0 is 0. So now I have 5 minus 0, which is 5. So what I want to do here is I want to add a decimal and add a 0. I'm allowed to do that because technically speaking, 5 is the same as 5.0. But since I added a decimal here, I have to add it up here as well. I'm now going to bring down my 0 to make the 5 into a 50. Now, how many times does 8 go into 50? 6 times, because 8 times 6 is 48. Now, I'm going to subtract 50 from 48 to get a remainder of 2. I'm now going to add another 0 because 5.0 is the same as 5.00. Now, this becomes a 20. So, how many times can 8 go into 20? 2 times. 8 times 2 is 16. 20 minus 16 is going to be 4. I'm now going to bring down another 0, and this 4 becomes a 40. How many times can 8 go into 40? 5 times. Hence, 40 minus 40 is 0, and my final answer is 0.625. So 5 over 8 is 0.625. Now, I'm also going to show you another method to solve for this. Now, recall I told you to memorize those fractions from the last slide. So recall that 1 over 8 is 0.125. Great. Now, to find 5 over 8, recall that for fractions, technically speaking, if I add 1 over 8 to itself 5 times, I'm simply going to get 5 over 8 because if you recall, since the denominators are all the same, I simply just add the numerator values. So I get 5 over 8 here. So to find this answer, I can simply write 0.125, either times it by 5, or I simply add it together 5 times, right? So I can simply write a column method here and add it together 5 times to get my final answer. And if you do add it together 5 times, you are just going to get 0.625. But if you want to think about it differently, there's another way to solve this as well. Recall that I also said 1 over 8, right? I also said that 1 over 8, technically speaking, it's half of 1 quarter. And it's half of 1 quarter because technically speaking, 0.125, if I add that to 0.125, which you recall, I'm adding 1 over 8 to 1 over 8. So that's going to be 2 over 8, right? But 0.125 plus 0.125 is 0.25. So that's 2 over 8. But isn't 2 over 8 actually just 1/4 as an equivalent fraction? That's 1/4. So if that's true, from what I said, that 1/8 is half of 1/4, half of a half is actually 1/4. Hence, if I had 4 over 8, it would be 1/2. And 1/2 is just 0.5. So if I know that, then why can't I just do 4 over 8 plus 1 over 8 to get to 5 over 8? This is another way of thinking about it. So in this case, that would be 0.5 plus 0.125, because 4 over 8 is just 1/2. So in this case, I would still end up getting 0.625. Okay, let's try another example. I got 2 over 9. Okay, so 2 divided by 9. So I got 2 on the inside because it's the numerator and 9 on the outside. Now, if I were to use long division, let's try. How many times does 9 go into 2? 0 times. 9 times 0, 0. Subtract that. 2 minus 0, 2. Now I add a decimal because 2.0 is the same as 2. And I have to add a decimal up here as well. I bring down the 0. That's now 20. How many times can 9 go into 20? 2 times. 9 times 2, 18. Subtract that, I get a 2. I bring down another 0 because 2.0 is the same as 2.00. And I'll get another 20. Now, how many times can 9 go into 20? 2 times again. So 2 times 9 is 18. Subtract that, I get a remainder of 2 again. Do you notice the pattern here? If I add another 0 and bring it down, that's now 20 again. 9 can go into 20 another 2 times. 9 times 2 is 18. Subtract 20 from 18, I get another remainder of 2. Hence, I simply get, if I have 2 over 9, I'm simply going to get 0.2 that goes on forever. And a way to write a number that goes on forever is to use the repeating symbol. So I can simply write a dash above it and say 2 over 9 is 0.2 repeating. Now, or, keyword is or, since I asked you to remember those fractions, recall that 1 over 9 is actually 0.111111 ... which is 0.1 repeating. So technically speaking, if I add 1 over 9 to 1 over 9, I just get 2 over 9. So if I'm adding 0.111111 to itself, ... I'm simply just going to get 0.22222... 0.2 that repeats forever. So hence, I can just say 2 over 9 is just going to be 0.2 repeating then. So notice how that may or may not be faster depending on how comfortable you are with long division. If you're not comfortable with long division, just simply try to memorize those base fractions. The important ones would be 1/3, 1 over 6, 1 over 7, 1 over 8, and 1 over 9. Those are the hard ones to remember, right? If you can memorize 1/2, 1/4, 1/5, 1/10, that'd be great too. And that would save you some time.